Hey math fans, welcome to this video where we'll be discussing equivalence relations. But before we dive into that, let's first talk about what are relations. A relation is simply a way to connect two things or objects. For example, you might say that two people are related if they are siblings or cousins. In mathematics, a relation is a set of ordered pairs that connects two sets. For example, if we have two sets, A and B, a relation R is a set of ordered pairs AB, where A is an element of A and B is an element of B. Or more formally, a relation between sets A and B is a subset R of A by B. We read this ordered pair AB belonging to R as A is related to B, and we write this as ARB. You might also see relations written as A tilde B. For example, the set of all people in a room can be related to the set of their ages by a relation that associates each person with their age. In this case, the relation consists of pairs of the form person-age, wherein every person can be mapped to an age. Now, let's talk about equivalence relations. An equivalence relation is a special type of relation that satisfies three properties: reflexivity, symmetry, and transitivity. Reflexivity means that every element is related to itself. In other words, for any element A in a set, we have ARA, where R represents the equivalence relation. This means that the relation is reflexive. For example, the equality relation equal is reflexive, since every element is equal to itself. Next, the symmetry property states that if two elements are related, then their order doesn't matter. In other words, if A is related to B, then B is also related to A. This means that the relation is symmetric. For example, the relation is the same age as between people is symmetric, since if person A is the same age as person B, then person B is also the same age as person A. Finally, transitivity means that if A is related to B and B is related to C, then A is related to C. In other words, if A are B and B are C, then A are C. This means that the relation is transitive. For example, the relation is divisible by between integers is transitive. Since if 12 is divisible by 6 and 6 is divisible by 3, then we know that 12 is divisible by 3. Now, let's look at a few examples to make this concept clearer. Consider the set of all people in the world. We can define a relation between two people as follows. Two people are related if and only if they have the same name. This relation is reflexive because everyone has the same name as themselves. It is symmetric because if person A has the same name as person B, then person B has the same name as person A. And it is transitive because if person A has the same name as person B and person B has the same name as person C, then person A has the same name as person C. Therefore, this relation is an equivalence relation. Here's another example. Say S equals n by n. Let's define the relation on S such that the ordered pair AB is related to the ordered pair CD if and only if A plus D equals B plus C. Let's start with showing this is reflexive. Let AB be in n by n. Then A plus B equals B plus A. Thus, AB is related to AB. For symmetry, let the ordered pairs AB and CD be in n by n. Let's first suppose that AB is related to CD. Therefore, we know that A plus D equals B plus C because AB is related to CD. So, C plus B equals D plus A. Thus, CD is related to AB, and therefore the relation is symmetric. For transitivity, let the ordered pairs AB, CD, EF be in n by n. Let's suppose that AB is related to CD and CD is related to EF. We know that A plus D equals B plus C and C plus F equals D plus E because AB is related to CD and CD is related to EF. If we add these two equations together, we get A plus C plus D plus F equals B plus C plus D plus E. And then subtract C plus D from both sides to get A plus F equals B plus E. We have AB is related to EF. Therefore, this relation on S is an equivalence relation because it is reflexive, symmetric, and transitive. To make this concept clearer, let's look at another example. Consider the relation on R defined by x is related to y if and only if x minus y is in Z. That is, if x minus y is an integer. Let's first check for reflexivity. Let x be an element in R, then x minus x equals 0, which is therefore an element of Z. Therefore, x is related to x and the relation is reflexive. Now for symmetry, suppose x is related to y, so x minus y is in Z. Since the negative of an integer is indeed an integer, y minus x is in Z, and hence y is related to x, and the relation is symmetric. Now for transitivity, suppose x is related to y and y is related to Z. Then x minus y is an element of Z and y minus z is an element of Z. But the sum of integers is an integer. So if we rewrite x minus z to x minus y plus y minus z, we can see x minus z is indeed in Z. Therefore, x is related to Z and the relation is transitive. And thus, the relation is for sure an equivalence relation. Now, let's look at an example that is not an equivalence relation. Suppose the relation is less than or equal to is a relation on the set of real numbers. What we have is that for any x, y, z in R, less than or equal to is reflexive and transitive, but may not be symmetric. For reflexivity, we have x is less than or equal to x, which is of course true since x equals x. For symmetry, if x is less than or equal to y, then it is not necessarily true that y is less than or equal to x. For example, 4 is less than or equal to 6, but 6 is not less than or equal to 4. For transitivity, if x is less than or equal to y, and y is less than or equal to z, then it is indeed true that x is less than or equal to z, since x is less than or equal to y, which is less than or equal to z. Thus, since the relation is less than or equal to is not symmetric, it is therefore not an equivalence relation. To summarize, an equivalence relation is a relation that satisfies the three properties of reflexivity, symmetry, and transitivity. Equivalence relations show up in many different areas of mathematics and beyond, and they're an important tool for understanding how different things relate to each other. They allow us to group elements of a set based on certain properties, which can help us better understand the structure of the set. Alright, thanks for watching. I hope this video helped you understand equivalence relations and how they relate to other types of relations. I hope this video was helpful in understanding what equivalence relations are. If you have any questions or comments, please leave them below. And don't forget to subscribe for more math-related content. Take care.